Hello everyone, my name is Charita. I am pursuing my graduation in Sri Venkateshwara College of Engineering, Computer Science Department. In this video, I am going to talk about pointer aliasing in microcontroller and embedded systems. The subject code for the microcontroller and embedded system is 21CS43. Now, let us get into the topic pointer aliasing. Pointer aliasing is a hidden kind of data dependency that can occur in C, C++, or any other language that uses pointers for array addresses in arithmetic operations. Array data identified by pointers in C can overlap because the C language puts very few restrictions on pointers. If a function has two pointers, that is PA and PB, with the same value, we say the pointers alias each other. Here, PA is a pointer A and PB is a pointer B. This introduces constraints on the order of instruction execution. If two write accesses, that alias occurs in program order. They must happen in the same order on the processors and cannot be reordered. Next, pointer aliasing happens when a single memory location is accessible through different symbolic names in the program. The name pointer alias applies specially to accessing the memory location through pointers, although the same effect can be achieved when accessing the memory location through references or any other way. Pointer aliasing is notorious for breaking compiler optimizations and introducing hidden loop dependencies. Consider the following example: void foo, double pointer A, double pointer B, and int n. Here they have used a for loop for int I equals to 0 where I is less than n increment of the I. In case pointers A and B point to distinct memory blocks, this the function with the following argument. If this is the case, pointers A and B alias and the loop cannot be parallelized because of loop carrying dependency. Next, we are going to talk about the performance implications of pointer aliasing, how it works, how the pointer alias performed. Pointer aliasing can have a severe impact on the program performance. Understanding its implication is critical to write high performance code. These documents provide a brief introduction to the problem and suggest several approaches to solving it through source code restricting compiler options and C or C++ language extensions. Next, aliasing. Here we are going to see about the brief and aliasing and with a function. Now let us look into the aliasing. Here is a brief overview of aliasing. Consider the following function. Here void process data float in, float out, float gain, int n sams where int I for loop for I equals to 0, I is less than n times an increment of the I, where next out of I equal to in of I into gain. In C or C++, it is legal for the parameters in and out to point to overlapping regions in memory. When this happens, in and out are said to be aliases. When the compiler optimizes the function, it does not in general know whether in and out or aliases. It must therefore assume that any store throughout can affect the memory pointed to by in, which severely limits its ability to reorder or parallelize the code. For some simple cases, the compiler could analyze the entire program to determine that two pointers cannot be aliases. But in general, it is impossible for the compiler to determine whether or not two pointer are aliases. It is not impossible for the compiler. So, to be safe, it must assume that they are. In the code above, the compiler must issue the instructions in roughly the following order. The code here is simplified a little bit. In this code, the compiler decided that there was no benefit to enrolling the loop because of the limited options for reordering. There are only the limited options for the reordering the code. This version theoretically requires 8 cycles per iteration. In case of theoretically, it requires 8. In case of practical, will be using the maximum or minimum iterations, more than 8 or less than 8 iterations. Here is the code which consisting of the 8 cycles per iteration. Next, avoiding pointer aliasing. How to avoid the pointer aliasing, its performance, and it is too much complicated. So how to avoid the pointer aliasing? Here we are going to see. Do not rely on the pointer. Do not rely on the compiler to eliminate common sub-expressions involving memory access. Instead, create new local variables to hold the expression. This ensures the expression is evaluated only once. Avoid taking the addresses of local variables. The variable may be insufficient to access from then on. This is about the methods and the of avoiding the pointer aliasing. In this video, we have talked about the pointer aliasing, the performance implications of the pointer aliasing, and how the pointer aliasing functions. Thank you all for watching this video. Please do like, share, and subscribe to my YouTube channel. We'll meet in the next video. Thank you all.